You just finished dinner, your plate is clean, your stomach is full. And somehow, you are already thinking about dessert. Not because you are hungry. You are not hungry. Something else is happening inside you. Something ancient and strange and far more powerful than hunger. And once you understand what it is, you will never look at a meal the same way again. The story of why you eat past the point of fullness does not start in a kitchen. It starts on a savanna about 2 million years ago, where your ancestors faced a problem that would quietly rewire the human brain forever. Food was not guaranteed. There were no refrigerators, no grocery stores, no scheduled meal times. There were long stretches of nothing, days, sometimes weeks, where calories were almost impossible to find. And then, suddenly, there was an enormous amount of food all at once. A successful hunt, a fruit tree in full bloom, a river full of fish at the right season. In that world, the smartest thing a body could do was eat as much as possible the moment food was available, not until full. Until the food was gone. Your brain learned that lesson. It learned it so well that the lesson is still running inside you right now, at every meal, every snack, every late-night reach into the refrigerator. Researcher Stephen Guyenet, author of The Hungry Brain, spent years mapping the neural circuitry behind overeating. What he found was not a failure of willpower, it was a success of evolution. The brain regions that drive eating, the hypothalamus, the nucleus accumbens, the dopamine reward circuit, were not designed to stop at enough. They were designed to stop at no more available. That is a critical distinction. Your stomach sends a fullness signal. It takes about 20 minutes to reach your brain, but your reward system is sending a parallel signal, a much louder one, that says, there is still food in front of you. The environment says, keep going. And for most of human history, that signal was correct. The problem is that the environment changed. Your brain did not. This mismatch has a name. Researchers call it the evolutionary mismatch, a gap between the world your biology was built for and the world you actually live in. Your ancestors never had to resist a restaurant-sized portion. They never had to navigate a grocery store engineered by food scientists to trigger maximum consumption. They never encountered a cookie designed in a laboratory to hit precisely the right combination of fat, sugar, and salt to make your reward system scream for more. David Kessler, former commissioner of the U.S. Food and Drug Administration, called this the hyper-palatable food trap. In his research, he found that certain combinations of ingredients, specifically fat, sugar, and salt in high concentrations, activate the brain's reward pathway the same way some drugs do. Not metaphorically. Literally the same neural cascade. The dopamine spike, the craving loop, the loss of a clear stopping point. Your brain was built to chase calorie-dense foods aggressively. Fat and sugar were rare in the ancestral world. Finding them was a survival event, so your reward system treats them as a survival event every single time, no matter how recently you ate. And then there is something even stranger at work. Scientists call it sensory-specific satiety. It was documented in detail by researcher Barbara Rolls at Penn State University. The principle is this: you do not get tired of eating in general. You get tired of eating the same thing. Your taste receptors down-regulate for whatever flavor you have been eating. The first bite of something sweet is the most powerful. By bite 10, the pleasure is fading. By bite 20, you are barely registering it. But introduce a new flavor, something salty, something savory, something crunchy. And the response resets entirely. Full capacity. Maximum pleasure signal. This is why you can eat an entire bowl of pasta and then immediately have room for dessert. Your stomach did not physically expand. Your pasta receptors simply became temporarily quiet. Dessert is a new sensory input. Your brain treats it as if you have not eaten at all. Your ancestors never encountered a 5-course meal. This mechanism was never designed to be abused, but the modern food environment abuses it perfectly, automatically, at every single meal. Now add one more layer: stress. When your body is under stress, real or perceived, your cortisol levels rise. Cortisol is an ancient survival hormone. It tells your body to seek caloric density. It increases cravings for fat and sugar specifically, not vegetables, not protein, the most calorie-dense options available. In the ancestral world, stress usually meant a threat, a predator, a drought, a conflict. After a threat passed, calories were needed to recover. So the brain learned to crave them during stress and immediately after. You have not faced a predator today, but your body cannot tell the difference between a physical threat and a deadline, an argument, or a difficult piece of news. The cortisol rises, the cravings follow. This is not weakness. This is your nervous system doing exactly what it was designed to do. In the wrong century. What makes all of this stranger still is that your brain can override the fullness signal not just through stress and reward, but through pure vision. Research published by Brian Wansink, while at Cornell University, showed that people consistently eat more when they cannot track how much they have consumed. Larger bowls, bottomless soup refills, dim lighting. All of them disconnect the visual feedback loop that helps the brain estimate intake. Eat from a bigger plate, and your brain codes the same amount of food as less food, because the ratio is different. Your stomach is sending one signal, your eyes are overruling it. So, here's where you are. You sit down to eat. Your reward system is primed to chase fat and sugar as if they are rare. Your sensory-specific satiety is about to let you eat across multiple flavor categories with no clear stopping point. If you are stressed, your cortisol is pushing you toward the most caloric options, and the visual environment you are eating in is almost certainly designed to make you undercount. You are never fighting hunger. You are fighting 2 million years of finely tuned survival machinery in an environment engineered by experts to exploit every single one of its settings. There is something almost elegant about it. The same system that kept your ancestors alive through brutal winters and empty savannas now makes it hard to stop at one handful of chips. Tonight, when you finish dinner and find your hand moving toward the breadbasket, even though you are full, you will know what is actually happening. It is not you failing. It is you succeeding at being exactly the kind of animal that survived long enough to become you. The only problem is the world's caught up to your biology and sprinted right past it. And your brain is still back on the savannah, eating as much as it possibly can, because it does not know the food will still be there tomorrow.